Inductance is defined as the ability to store moving electrons in a form of magnetic field while opposing current changes. Also, inductance is directly associated to the material permeability, where it could be low or high and according to the material formation. The device that stores electric current is called an inductor. The inductor is consisted of a magnetic core and a coil. The coil is made of a conducting winded material, such as copper or aluminum, wrapped around the core. The core, on the other hand, is made of a magnetic material, such as air or iron. Essentially, the core of an inductor, and according to its permeability, increases the inductor's inductance, as it could be air or ferromagnetic. The inductor's core shapes can also vary, as it could be toroidal, rod-shaped, or even nothing but air. In addition, copper wire is mostly employed as the winding material in inductors. This wire is winded many times to form a coil. The purpose of this winding is to enhance the magnetic field strength by getting the electrons passing across numerous ends rather than only two ends, which results in enlarging the magnetic field across the inductor and hence increasing its inductance. When an electric current starts running through an inductor, the inductor initially shows some resistance to the flowed electrons. This resistance is caused by the inductor as it starts absorbing the flowing electrons generated by that magnetic field across it. When the inductor is saturated, the resistance will disappear and the inductor starts acting as a normal wire. When the external current source is eliminated, the inductor releases its stored energy in form of significant voltage discharge, aiming to stabilize the electric circuit. In other words, the inductor is continually working on keeping the electric circuit stable. Since the alternating current is frequently changing, then the inductor will continually be impeding and preventing it from passing through it. However, and since the direct current does not change over time, then it passes through the inductor, creating a constant magnetic field. There are some factors that influence the inductance strength, such as, first, core material permeability. As larger the permeability, as larger the inductance. Second, geometrical formation. As greater the turns of coil, as greater the inductance. The geometry of the inductor, which its inductance is increased when the wire is shaped as a coil or helix. Material's inductance is measured in Henry, while material's permeability is measured in Henry per meter. That was the fourth element that has an effect on the electric circuit. Also, the final episode of this series. We hope that you enjoyed it and got an idea about Electromagnetism Foundation. Wait for the next series and ensure that you're subscribed and click the bell icon. Please help us by liking, commenting, and sharing. This encourages us to deliver more. Wait for the next video on the Electricity and Magnetism channel, and we'll see you in the upcoming series.